Okay, this is the video for the pre-quiz on classical probability, and this will be page 1. This will be broken into 3 videos, one video per page. All right, so the very first question says, if the probability of A equals 0.3 and the probability of B is 0.5, what is the probability of A union B if A and B are independent? A few things about this type of problem. When we're working, normally I would say don't write down your formulas, because if you write your formula down and you write it incorrectly, AP is going to count off points for it. But on this type of problem, I really think you should be writing the formulas down. So let's look at this. We have the probability of A union B. The probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Now, what I have here is I start plugging in, and I go, okay, this is 0.3 plus 0.5. But I don't know what the intersection is. But they tell me something. They tell me that they are independent. All right. Well, if they're independent, we know that the probability of A and B equals the probability of A times the probability of B. So I can go ahead and plug in here, and I have equals 0.3 times 0.15, and I find the probability of A and B equals that probability. Excuse me, 0.5, and that equals 0.15. So I end up with 0.3 plus 0.5 minus 0.15, and that gives me 0.8 minus 0.15, which is 0.65. Now, some students, all they gave me was this. That's full credit. That's showing me everything. But if any one of those numbers is wrong, I can't help you out with partial credit. Another thing that you could have done is you could have shown this substitution early. I could have substituted this into this equation early, and that would have been fine as well. But I would initially start with this, and remember, this is true only if independent, only true if independent. Okay, next problem. Suppose the probability of X equals 0.35 and the probability of Y equals 0.4. If the probability of X given Y equals 0.28, what is the probability of Y given X? Well, at this point, I'm going to need to be working with what is that formula to figure out what I'm doing. So let's start off with that, because we know that value. So we know probability of X given Y equals the probability of X and Y over the probability of Y. And I can go ahead and plug in. And when I plug in, this is 0.28 equals, and what else do we have? We have the probability of Y. So we don't know the probability of X and Y, but 0.28 over 0.40. And when I go ahead and multiply that out, I don't have my calculator ready. 0.28 times 0.4 equals 0.112. So the probability of X and Y equals 0.112. Well, that's helpful, but that's still not what we're looking for. We're looking for the probability of Y given X. Well, once again, let's look at our formula. Probability of Y given X equals the probability of X and Y, the intersection, over this time the probability of X, because that's what's given. Well, what do we know? Well, we know that X is 0.35, and on the other side of things, we found out this was 0.112. Divide that out, and we find out the probability of Y given X equals 0.32. Now, once again, I will say something. Normally writing down formulas is a little bit dicey because if you copy them down, if you write them incorrectly, College Board will count off for them. But this is a formula that I feel like you should be writing down. However, if all you show is this and this, you will receive full credit. But I would recommend showing at least one of these two, if not both of these formulas. Okay. All right. So next one. Given the probabilities A equals 0.3 and A union B is 0.7, what's the probability if B, what is the probability of B if A and B are mutually exclusive, and then if they're independent? So we have two separate problems here. So we have the probability, and once again, not required to write the formula, and if you write it incorrectly, you will lose points, but anytime it's one of these, I highly recommend it. So for the mutually exclusive, probability of A union B equals the probability of A plus the probability of B minus the probability of A and B, because that formula is true regardless, always, every single time. So we plug in and we go, this is 0.7 equals A is 0.3, B we don't know, and but we're talking about mutually exclusive. When we're mutually exclusive, there's no overlap, there's no intersection, so we're subtracting 0. All right, I think for a lot of you, it would actually help if you wrote down that you're subtracting 0 so that you don't forget what you're doing. So then, but it's not required. If you just want to go, hey, I dropped it off, that's fine. So I do my subtraction and I find out 0.4 equals B. And so that would be the case if they're mutually exclusive. And I need to label that as mutually exclusive. I'm not doing it here just to speed things up for the video purposes. All right, so now we need to do independence. Well, if they're, first off, we know the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. Excuse me, slide that over just a little bit. We also know if they're independent, and we're assuming they are because we're trying to do this problem based on independent. If they're independent, the probability of A and B equals the probability of A times the probability of B. So I can substitute that in, and now I have the probability of A union B equals the probability of A plus the probability of B minus the probability, and I substituted this in right there, A times the probability of B. At this point, it becomes an algebra problem, and I'm probably going to run out of room and have to use a separate sheet of paper. So I have 0.7 equals the 0.3. We don't know what B is, minus 0.3 times B, and that's supposed to be a 0.3 times a B. 0.7 minus 0.3 is 0.4. And if I have 1B minus 0.3B, I end up with 0.7B. I divide by both sides by 0.7. This goes away, and I end up with B equals, or the probability of B equals 4/7. All right, and I would need a probability of B equals 4/7 if independent. Please put those labels on there. We're not taking off on this, but could help you, could hurt you in the long run. So please make sure you're labeling that. All right, very last one on this page, and this was in this video. Given that B equals 0.45, F is 0.32, and E union F is 6.26, are events E and F independent? Okay. Once again, I have this formula, all right? With this formula, I can go, okay, probability of E union F equals the probability of E plus the probability of F minus the probability of E and F. And I plug in. And once again, I didn't have to write this formula, but I definitely need to show all the work that goes with it. And I think for these, this type of problem, I think is very useful. Equals 0.45 plus 0.32 minus probability of E intersect F. And so I end up with 0.626 equals 0.77 minus the probability of E intersect F. And doing some really quick math on a calculator, 0.77 minus 0.626. And I end up getting 0.144. So 0.144 equals the probability of E and intersect F. That doesn't prove anything. That's what this has to be. So then if independent, and you don't have to write this, this is for your benefit. If independent, we know the probability of E times the probability of F equals the intersection, and I'm just going to write it like that because I'm running out of room. So in this case, 0.32 times, or 0.45 times 0.32. 0.45 times 0.32 equals 0.144. Therefore, the events are independent. All right. Why? Because this intersection equals this, what we calculated it having to be. Now, that's not the only way you could have approached this problem. All right. The other way you could have approached this problem is once you had this intersection right here, once you've calculated this part, you could go, well, the probability of E given F equals the probability of E intersect F over the probability of F. And in that case, we know that's true. And if that's the case, this has to equal probability of E. So if I take the intersection, 0.144, and divide it by 0.32, it equals 0.45. Therefore, the events are independent. But you have to say, because they're equal, therefore they are independent. If they're not equal, then you have to say they are not equal, therefore they're not independent, or because the events are not equal, they are not independent. All right. And because my writing may not be that great, here's problem 1 and 2. And you can pause the video if you need to on that, but there they are. And here are the solutions to problems 3 and 4. And once again, pause the video if you need that information. All right, hopefully that will be a helpful review for you guys. The next video will be on the contingency table. And there were some common errors, so you may want to watch that as well.